Hi guys, this is going to be the start of sketching quadratics, and just like in previous chapters where we've looked at linear equations and then graphing linear equations which showed a straight line, we've covered quadratics, and now we're going to sketch those quadratics. What you'll find with quadratic formulas, you'll get a graph that looks like a parabola. A parabola is basically a graph that is like a U shape or an upside down U shape. You might want to look at the equation of a certain curve of a roller coaster ride. Maybe look at the pathway when you throw a ball up in the air and then the moment it comes back down. Or possibly maybe a stream of water from a fountain. Just looking at that and identifying the path. So your quadratic rules are going to be something in the form of y equals x squared. Possibly another option would be y equals 2x squared minus x minus 3. Another option could look like y equals x minus 1 squared. So you've got perfect squares. Or you could have something like y equals x plus 4 all squared minus 7. All of those type of equations, quadratic formulas, will provide a parabola. Here we have a few options here, and just like linear equations, we will substitute these values of x into these quadratic equations. Okay, so negative 3, if y equals x squared, negative 3 squared is going to be 9. Okay. Negative 2 squared will be 4, and then we'll move on and then complete the table. Okay, so what you'll notice is that with y equals x squared, which is going to be the base quadratic or parabola that we'll compare other ones to, notice that it starts up high at negative 3, okay, and then as it moves along the x-axis, it goes down. Okay, down to 0. So it starts at 9 and then it'll move to 0, and then after 0 it kind of goes back up again. Okay, so if we plot the first one in, so minus 3 and 9 is up here. Okay, minus 2 and 4 is here. Minus 1 and 1 is here. Then we've got 0 and 0. Then it goes back up like so. And then you'll have this parabola that looks like that. Okay, so this I will label as y equals x squared. The difference between y equals x squared and y equals minus x squared is that it's negative. And so just like a linear equation where you have a negative gradient, where it's instead of going up, it's actually going down, it's going to be exactly that. So you have a negative parabola, and you'll find that instead of starting up the top, going down and going back up, it's actually going to be a frown. Okay, instead of a smile, it's going to be a frown. So it will start here and then it will move on to here, here, back to 0, then across, and then back out again. So you'll find that this is y equals negative x squared. Okay, so this line here is y equals minus x squared. Now we have y equals x minus 2 squared. Okay, so minus 3 is x, minus 3 minus 2 is minus 5. Minus 5 squared is 25. Notice that it starts up high. Okay, it's off the chart. So somewhere up here, when when x is minus 3, y equals 25. So it's probably somewhere up the top of this page. Then when x is minus 2, it will go to 16. When it goes to x equals 1, then where am I up to? X is minus 1, then y equals 9. So minus 1 and 9. Okay. Moving along, when x is 0, y is 4. And then 1 is 1 over here. And then it goes 2 to 0. And then it starts making its way back up again. Okay, so what we can do here, if we join the dots, make a nice curve about it, I'm actually going to add these points in and just make a dotted line just to show where, if we continued along the x-axis, where this parabola would actually continue. Okay, so this one is going to be y equals x minus 2 squared. The last one that we have on the table is y equals x squared minus 3. I've got it here for you. So it starts up on the top at 6. So I'll do this in a different color again. So y, when x is minus 3, y equals 6. So I'll put up there. When x is minus 2, y equals 1. When x is minus 1, y equals negative 2. So it comes down there. 0 at minus 3. 1 at negative 2. So it starts going back up again. And then 2 at 1. So we'll go up here. And then when x is 3, y equals 6. So x is 3, y equals 6. It comes back down there. So join the dots. There you have y equals x squared minus 3. Okay. Now just have a look at the difference between y equals x squared and y equals x squared minus 3. Okay. The shape looks very much the same as the first one. So we know that if we have a negative x squared, it's going to be an inverted or an upside down parabola. Okay, that's one thing to take note of. If anything is negative, it's going to be upside down. But the only difference between y equals x squared and y equals x squared minus 3, we're subtracting 3. And you'll notice that in relation to its position, it's actually gone down 3 steps. So if we had x squared plus 3, we would comfortably assume that it will move from here to 1, 2, 3 and be a lot further up. The translation of that component on the quadratics will tell you how far up or how far down it will go in relation to y equals x squared. Now we'll see a few things like this later on, and hopefully it will start making more sense to you guys. But I just wanted to show you a few things here. With all graphs, there's always going to be a turning point. So where it goes down or hits a peak if it's going up, that turning point is always when it's going to go back the other way. So just to highlight some features, this is your turning point here. Okay. There will always be an axis of symmetry. So if we actually drew a line down the middle, okay, it will cut it down directly in half to make it look so you have a symmetrical half on both sides. And the same thing with this red one. If we actually had an axis of symmetry, we would actually put it where x equals 2, right down the middle there. Alright. Okay, next thing is that there are x and y intercepts. Not for all, but for some. Notice that with y equals x squared, it hits the origin at 0, 0, and it will just keep on going. And same with negative x squared. But where we have y equals x squared minus 3, it will pass the x-axis. And also with y equals x squared minus, x minus 2 squared, this parabola actually cuts through the y-axis. And throughout this chapter, we'll show you how to identify these key points. Okay, so the turning point and the intercepts. Great. The other point to take note of, that the turning point is also called the vertex. Okay, just a few things just to add on to parabolas, just introducing. Looking at just y equals x squared, your turning point is going to be at the origin. Okay, so as much as it may not be a real proper intercept, that's where it's going to locate. With any other ones, there will be an x-intercept or an y-intercept. The other thing, as mentioned previously, the turning point is also named as the vertex. Okay. Just really briefly, on this page, as mentioned, notice that the translation is a vertical translation when we subtract 3 to y equals x squared. It moves down 3 units compared to y equals x squared. If we add 3, it will surely go up 3 units. Okay. We're going to look at a few other things as well. I'm just, what I'm doing here, I'm just making the print a little bit clearer. This is y equals x squared. This wider parabola there is y equals half x squared. The one in the middle is y equals x squared, and the one on the inner side is y equals 2x squared. So notice that the coefficient is 2. Theoretically, with y equals x squared, the coefficient is 1. And with this widest parabola, the coefficient of x squared is a half. So as the number decreases, you can identify and be sure that your parabola is going to get a lot wider, okay? Or the gradient on the bottom of the parabola is going to be a little bit shallower. Whereas y equals 2x, or y equals 3x, y equals 4x, as the number increases, you're going to have a much skinnier and steeper parabola. So that is referred to your dilation. Okay. As mentioned also before in the previous page, looking here again, that your negative or positive symbol in front of x squared will actually show you, determine whether your parabola is going up or whether it's reflected and inverted. So here is y equals x squared, it's going the right way up, and this one here is y equals negative x squared, and it's the mirror image, so it's going downwards. When you have negative 2x squared, okay, not only is it inverted, so upside down, notice that the number is getting bigger, it's greater than 1. It's going to be the inversion or the reflection of y equals 2x squared. Okay, so it will be skinnier again. So hopefully you can put those two together and understand how it works. And if you were to make any analytical assumptions about a certain quadratic equation before graphing it, there are just a few little tips to get you going. So that is referring to the reflection. Okay. The third part is the translation here. So that is actually going to be moving left, right, up, or down. Okay. So this parabola there, I'll just show you the line. Maybe I'll trace it with a red to make it a bit easier for you to locate. That is y equals x squared, so that's what we're going to be comparing it to. Okay. Again, we had y equals x squared minus 3, so it's going to shift down 3 units, 1, 2, and 3. Okay. If it was plus 3, it's going to move up. Now, the other thing is, look at this here. I'm going to write down y equals x minus 2 squared, and this one is y equals x plus 3 squared. Okay. Now what you'll notice that this parabola here on the right is the same as y equals x squared, but it's actually moved 2 units to the right hand side. Okay, and then you have x plus 3 squared, and instead of moving to the right, that's going 1, 2, 3 units to the left. Okay, so positive 3 moves it to the left 3 units, and a negative 2 seems to move it to the right 2 units. And so, as I said, as this chapter progresses, we'll see more of this and be able to grapple a little bit more confidently. Okay guys, see you later.